A great day to one and all. To motivate our topic for today, suppose I give you this one: 1, 3, 5, 7, 9. So I just listed terms, and this is an example of a sequence, particularly a finite sequence, considering you have a limited number of elements. But how about this? How about if I have 1, 3, 1 plus 3 plus 5 plus 7 plus 9? What have you noticed? So if you could see, based on the first one, it's actually the terms of this sequence, but what I did was add all of them. So if you are now adding the terms of a sequence, then you have what we call a series. And so you might ask, what is a series? A series is the sum of the terms of a sequence. Like if you are given, for example, the first 5 terms, then that could be the sequence. Then to get the series, you simply add those 5 terms. So series is the sum of the terms of a certain sequence. And you could have either the sum of all terms, or the sum of all uh, terms of a certain sequence, I mean. But for our case right now, we will focus on what we call partial sum. Partial sum refers to the sum of the first n terms of a finite sequence. And the notation that I will be introducing to you for our class is this S sub n. S sub n denotes the sum of the first n terms of a sequence. That is, if I have here S sub n, and n here is a certain natural number, then this means that you have to add a sub 1, a sub 2, a sub 3, all the way until the last term, which is a sub n. So it's basically adding from a sub 1 until a sub n, where a sub 1 here is your first term, and your a sub n here is your last term, respectively, or your nth term, respectively. Now, for example, I would like you to find S sub 7 of the sequence 1, 3, 5, 7, 9, and so on. So you could see that this is in fact an infinite sequence, because you have a first term and you have no last term here. And since we are looking for S sub 7, then we will get the sum of the first 7 terms of this sequence. But you might ask, sir, there are only 5 terms here. Even though there are 5 terms, all you have to do is continue the pattern until you get the 6th and the 7th term, and adding all of them. If you could see here, what's the pattern? You have here a sequence of positive odd numbers. So we have here first, second, third, fourth, fifth. The terms are 1, 3, 5, 7, and 9. And if you could check, you could see that the 6th term will be 11, and that the 7th term will be 13. Hence, if you have S sub 7, then you will add the first 7 terms of this sequence. That is why I have here 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13, or doing this manually for now, gives you 49. Hence, S sub 7, or the sum of the first 7 terms of this sequence, is 49. I hope it's clear with us. Let's have some exercises. Find the indicated S sub n of each of the following sequence. Let's have the first one, which is 1, 3, 6, 10, 15, and so on. Let's find S sub 7. So if you could see here, we actually have from the first one, you have plus 2, which is 3, plus 3, 6, plus 4, 10, plus 5, 15. So the next one could be plus 6. So 15 plus 6 would give you 21. And 21 plus 7 will give you 28. Take note, we have to continue the pattern. And so S sub 7 is this expression. And adding this manually gives us 84. Hence, S sub 7 of the sequence 1, 3, 6, 10, 15 is 84. I hope you got it. And if you did, great job. Let's have letter B. It's defined by the sequence or by the function, particularly an explicit function, a sub n equals 2 times the quantity n plus 1 squared. And you're looking for S sub 3. And what does S sub 3 mean again? This means the sum of the first 3 terms of this sequence. Since we will get the sum of the first 3 terms, then we need the value of the first, second, and third terms. And explicitly speaking, we will represent or let n be equal to 1 to solve for the first term. Replacing all n's by 1, we have a sub 1 equals twice the square of 1 plus 1. So 1 plus 1 here is 2. You have to square first. So 2 squared is 4. 2 times 4 gives you 8. And 8 here is the first term. For the second term, we will let n be equal to 2. Replacing all n's by 2, you will have a sub 2 equals twice the square of 2 plus 1. 2 plus 1 is 3, so 3 squared is 9. And you have 2 times 9, which is 18. So 18 here is our second term. For the third term, we have to replace all n's by 3. So a sub 3 equals twice the square of 3 plus 1. 3 plus 1 is 4. 4 squared is 16. And 2 times 16 is 32. So the third term here is 32. And since we have the first 3 terms now, we can now determine the sum of these 3. So S sub 3 is equal to 8 plus 18 plus 32, which is 58. I hope you got this as well. All right. Let's have the third one. An arithmetic sequence with a sub 1 equals -5. D equals 4. And we're looking for the fifth term. The sum of the first 5 terms. We have to be very careful again. If I say a sub 5, for example, if I say a sub 5, I'm referring to the fifth term. But if I say S sub 5, I'm referring to the sum of the first 5 terms. So be very careful about it. Now, from here, we could see that recursively speaking, if your first term is -5, then remember that you are adding the common difference all throughout. So if the first term is -5, plus 4, your second term is -1. Plus 4, that gives you 3. Plus 4, 7. Plus 4, 11. We have to stop with 11 because we are just getting the sum of the first 5 terms. If you will continue the pattern, it might not be useful considering that you are getting the sum of the first 5 terms only. So with such, S sub 5 is equal to negative 5 plus negative 1 plus 3 plus 7 plus 11, and that gives you 15 as the value of S sub 5. I hope you understand this properly. And if ever you have questions or clarifications, feel free to reach me or open them up to me in the future. Or you can type your comments or suggestions in our chat box or probably in the comment section below. Now, as of this moment, I hope that the definition of series, particularly of partial sum, is clear with us. From this point forward, we will focus on arithmetic series. And when we say arithmetic series, it is the sum of the terms of an arithmetic sequence. So from this point forward, throughout the rest of the video, we will be adding terms of arithmetic sequences, particularly finite arithmetic sequences. When I say finite arithmetic sequence, it is an arithmetic sequence with a limited number of elements or with limited number of terms. Now, let's have a quick example. Let's say I have here an arithmetic series with the first term 5 with a common difference of 5. And I am getting here, and you could see here that we have 1, 2, 3, 4, 5, 6. So we have 6 terms. So we will be looking for S sub 6 of this particular series. And if we will look for the sum, let's try adding the first and the last term. First plus last term gives you 35. How about if I add the second and second to the last? That would be 10 plus 25, which is still 35. And if I will be getting the third, or the third from the last, or the two middle terms, 15 plus 20 will still give you 35. So you could see that we have 35s. And how many 35s or sum of 35s are there? You could see 3 pairs of numbers that add up to 35. And therefore, to get the sum of the 6 terms, or you have here S sub 6, that is equal to 3 times 35 because you have 3 sets of numbers or 3 pairs of numbers that add up or sum up to 35. And 3 times 35 is 105. Thus, S sub 6 of this is 105. You can verify this by manual counting from left to right. What others do is that they really begin from left to right, like 5 plus 10, that's 30, 15. 15 plus 15, 30. 30 plus 20, 50. 50 plus 25 is 75. 75 plus 30 is 105. So you could see either by manual addition from left to right or by using this method, still we were able to determine the sum of the first 6 terms, which is 105. I hope you got it. And if you did, great job. But if not, try working on these next ones. But before that, it's important first to generalize this. Let's determine the sum, S of n, of any arithmetic series. Suppose I have here the terms of an arithmetic series and take their terms of an arithmetic sequence and take their sum. So we have here a sub 1 plus a sub 2 plus a sub 3 plus dot 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 all the way until a sub n minus 2 plus a sub n minus 1 plus a sub n. So these are in order from left to right, from first to last term. If we will add the first and last, that would give us a sub 1 plus a sub n. And without loss of generality, or if we will follow the reasoning or the actual example in the previous slide, you could actually see that if you will add the second term and the second to the last term will still give you a sub 1 plus a sub n. And if you will add the third term and the third from the last term, it will still give you a sub 1 plus a sub n. And until such time that you have added all of the pairs here in the middle. But the next question is, how many a sub 1 plus a sub n's are there? That is, remember, you are taking them by pairs. And so to determine, remember, there are n terms here. And since there are two numbers involved in a pair, then we could say that there are n over 2 pairs of number that would add up to a sub 1 plus a sub n. For the meantime, I will assume that n here is an even natural number. And hence, to determine s sub n, based on the similar reasoning we did earlier, to get the sum of all of this, we have to multiply the number of pairs that add up to a sub 1 plus a sub n. Hence, multiplying these two, we have s sub n equals n over 2 times the quantity a sub 1 plus a sub n. Hence, to get the sum of any arithmetic series or the sum of the terms of an arithmetic sequence with n terms, and n is a finite or is a natural number, and that the series is finite, of course, then to get the sum of the first n terms, you simply divide the number of terms by 2 and multiply it with the sum of the first and the last term. So please take note of this formula because this will be very useful as well. Now, let's talk about an alternative formula. In our previous lesson, we remember that the nth term of a certain arithmetic sequence is a sub n equals a sub 1 plus the quantity n minus 1 times t. So from this formula, we could actually replace a sub n with a sub 1 plus n minus 1 times t, because remember, they are equal here. So this will become s sub n equals n over 2 times a sub 1 plus a sub 1 plus this, which is n minus 1 times t. Inside the parentheses here, we could add the two a sub 1s, and copying the rest gives s sub n equals n over 2 times the quantity 2a sub 1 plus n minus 1 times d. So this is another formula. That's why the sum of the first n terms of an arithmetic sequence s sub n, or simply your arithmetic series with n terms and that n is finite, is actually given by s sub n equals n over 2 times the quantity a sub 1 plus a sub n, or s sub n equals n over 2 times the quantity 2a sub 1 plus n minus 1 times d. And what is very good to note here is that this formula actually works regardless if n is an even or odd natural number. And the next question is, when is one formula better to use than the other? What do you think? You may pause the video and think for it, and let's confirm your answer. Remember this. It's better to use this first formula if what? If the last term of the sequence is given. However, I suggest that you use the other version of the formula if this longer version, if the common difference is given. Take note. First one, if the last term is given. The second one, if the common difference is given. Let's have an example. Find S sub 8 of the arithmetic sequence 4, 12, 20, and so on. From here, since we have S sub 8, so we will look for the sum of the first 8 terms of this arithmetic sequence, or you have your arithmetic series. So with that, we can see that the subscript here is 8. So this 8 is our n. The first term here is in fact 4. You see that common difference is given. So you subtract the second term by the first. 12 minus 4, that's 8. 20 minus 12, it's 8, and so on. So the common difference here is 8. So since the common difference is given, it's better to use the longer version of the formula, which is this one, by the way. S sub n equals n all over 2 times the quantity 2a sub 1 plus n minus 1 times d. Replacing all n's by 8 and substituting the value of a sub 1 and d, we have S sub 8 equals 8 over 2 multiplied by 2 times 4 plus 8 minus 1 times 8. I hope you got this so far. From here, you could see that 8 over 2 simplifies to 4. 2 times 4 is 8. 8 minus 1 here is 7. Times 8 gives you 56. So from here, 8 plus 56 simplifies to 64. And S sub 8 equals 4 times 64, or that's 256. Therefore, if you will list the first 8 terms of this arithmetic sequence and add all of them, expect to get a sum of 256. All right, so far, so good. Let's have the same example, but this time we will solve for the last term. Remember, we have S sub 8, so we will be adding until the 8th term. So this time, how about if we really solve for the 8th term? Using the arithmetic sequence formula, you have a sub n equals a sub 1 plus n minus 1 times d. And by substitution, you have a sub 8 plus 4 plus 8 minus 1 times 8. That is 7 times 8. So this is 56. 4 plus 56 gives us 60. So 60 is the last term, or the 8th term of this sequence. And since the last term is known, we may now use the shorter version of the formula. So replacing all n's by 8, you will have S sub 8 equals 8 over 2 times a sub 1 plus a sub 8. So I hope you're getting this so far. We see that I substituted a sub 1 with 4, with a sub 8 as 60. So what's inside the parenthesis simplifies to 64. 8 over 2 is 4. And multiplying 4 and 64 still gives us 256. So you see, whatever version of the formula you use, if your process is correct, then you can still arrive to the same correct answer. Okay, I hope you're doing well so far. Now, let's have another example. What is the sum of the first 9 odd numbers? For this case, we will let odd numbers be positive. So we know that we have the series 1 plus 3 plus 5 plus dot dot dot. Remember that odd numbers differ by 2. So starting from 1 plus 2, 3 plus 2, 5, and so on. We could see from here that our n is 9 because we're going to look for the sum of the first 9 terms. Also, our first term is 1, and our common difference here is 2. So for the meantime, I will be using the longer version of the formula because the common difference of 2 is known. With such, you have s sub 9 equals 9 over 2 times 2 plus 1, 2 times 1, which is 2, plus 9 minus 1 times 2. So this is 2. 9 minus 1 is 8 times 2, which is 16. So what's inside the parentheses simplifies to 18. And what others do is that they multiply 9 and 18 first before dividing by 2. That's okay. But if you wish to be fast, you could divide 18 by 2 first. So 18 divided by 2, that's 9. Then multiply that to your numerator. 9 times 9, which is 81. So I'm sure the sum here is 81. And if you did, great job. Let's have these exercises. Let's have the first one. The first two terms of an arithmetic sequence are 5 and negative 2. Find S sub 10. So since you are given here two terms, it's understood that the first number mentioned is the first term, and the second number mentioned is your last term. And since you're looking for S sub 10, then your n here is 10. And if you could see here, you actually know the common difference. Why? To get the common difference, you subtract the second term by the first term. So negative 2 minus 5, it's negative 7. So negative 7 is our common difference. That's why you have S sub 10 equals 10 over 2 times 2 times 5 plus 10 minus 1 times negative 7. 10 over 2 simplifies to 5. 2 times 5 is 10. 10 minus 1 is 9. 9 times negative 7 is negative 63. Their sum inside the parentheses here becomes negative 53, and multiplying them gives S sub 10, which is negative 265. I hope you got this as well. Number 2. An arithmetic sequence has the first term 1 and a third term of 11. Find the common difference and the sum of the first 7 terms. We have to recall that the largest subscript here is 3. So let's represent n as 3. If we do now, we are given this explicit formula of an arithmetic sequence. Replacing all n's by 3, what do we get? We will get the following. A sub 3 equals A sub 1 plus 3 minus 1 times D, or that's A sub 3 equals A sub 1 plus 2D. Knowing that A sub 3 here is 11 and A sub 1 is 1, and by substitution, you will get 11 equals 1 plus 2D. Subtract both sides by 1. You have 10 equals 2D. Dividing both sides by 2 gives the common difference of 5. And since you have the value of your common difference, it's better to use the longer version of the formula with D. So you have here this formula. Since we are looking for S sub 7, all n's will be replaced by 7. So you will have S sub 7 equals 7 halves times 2 times 1 plus 7 minus 1 times 5. Where did I get 5? This is your common difference, and the rest were just given. So from here, 7 over 7 is an odd number, so 7 halves. Let's not simplify it for now. This is 2 times 1 is 2. 7 minus 1 is 6 times 5, which is 30. So 2 plus 30 will be 32. 30. I suggest that you divide first the 32 with 2. 32 divided by 2 is 16. And 7 times 16 is 112. All right. So far, I'm hoping so good. Number 3. In the sequence 25, 30, 35, and so on until 195, find n and the sum of these terms. From this one here, you could actually see from this given that the first term is 25. Your common difference is 5. How come 5? 30 minus 25, that's 5. 35 minus 30, it's 5, and so on. That is, if you subtract a value of a term by its immediately preceding term, then you will get a constant value, which is 5. So D is 5. We know that 195 here is the last term. So we will let 195 be a sub n for now. By substitution to this formula, we have 195 equals 25 plus n minus 1 times 5. Our goal here is to solve for the value of n, which is the number of terms. Subtracting both sides by 25 gives 170 equals n minus 1 times 5. Dividing both sides by 5, so we have 170 divided by 5 will be 34. The right-hand side divided by 5 will be n minus 1. And adding 1 both sides, you will get the value of your n, which is 35. And what does this mean? This means that there are 35 terms from 25, 30, 35, all the way until 195. So if you list everything without the use of your ellipsis, I'm sure that you will list 35 of them in all. And since we know now the value of our n, and you are given the common difference 5, so we can, and note, by the way, you could utilize either of the formulas because anyway, we know the last term, which is 195, that's your a sub n. We also know the common difference, so whichever is applicable. For now, I use the shorter version of the formula. So S sub 35 equals 35 halves times 25 plus 195. The 1 inside the parentheses simplifies to 220. 220 divided by 2 is 110. Hence, S sub 35 is equal to 3,850. So therefore, if you will add 25, 30, 35, all the way until 195, expect that the sum will be 3,850. I hope you are doing great so far. Number 4. In an arithmetic sequence, it is known that a sub 3 equals 7 and a sub 7 equals negative 5. Find the common difference, a sub 1 and s sub 12. So let's do this. By the way, if you wish, feel free to solve the problem before attempting to continue with the video. Okay, so our given is a sub 3 equals 7 and a sub 7 equals -5. And we have this explicit form of your arithmetic sequence, replacing all n's by 3 first, because that's your subscript here. Then you will have a sub 3 equals a sub 1 plus 3 minus 1, or 2d. 2 times d you have here, plus 2d. So the third term is a sub 1 plus 2d. But note that the third term is also 7. That's why a sub 1 plus 2d is equated with 7. Also, since you have here your second given, which is a sub 7 equals -5, your subscript here is 7. So your n here must be 7. Replacing all n's of your explicit form here by 7, you will have a sub 7 equals a sub 1 plus 7 minus 1, that's 6, times d, 6d. So the seventh term is a sub 1 plus 6d. But I have to equate a sub 1 plus 6d with -5 because that is its value based on the given. Now, what will happen next is that we will perform elimination. Doing such, I will copy these two equations and I will perform subtraction with the intention of eliminating the a sub 1. So subtracting both sides, a sub 1 minus a sub 1 is 0. 6d minus 2d, it's 4d. -5 minus 7 is -12. So we have here 4d equals -12. Dividing both sides by 4 gives d, or your common difference, of -3. I think this is sensible, since as you have a term with a higher subscript, it became lower. The value became lower. So it's natural to have a negative common difference in this case. It shows, or it is expected in a way. To determine the value of a sub 1, I could substitute there either in the first or in the second equation here. I chose the first one. So a sub 1 plus 2d equals 7. And replacing d with -3, I have a sub 1 plus 2 times -3 equals 7. 2 times -3, it's -6. And plus 6 both sides. So you will get a sub 1 equals 13. So 13 is the first term of this sequence. So now we can solve for the value of s sub 10, knowing that we have your a sub 1 and your common difference. I will utilize, solving for s sub 12, we have this, I have to use the longer version of the formula with that's using d because it's known, and replacing all n's by 12, you will have s sub 12 equals 12 over 2 times 2 times 13 plus 12 minus 1 times -3. 12, in this case, 12 over 2 is 6. 2 times 13 is 26. This is 11 times -3, which is -33. The numbers inside the parentheses simplifies to -7. Therefore, the sum of the first 12 terms of this sequence is -42. I hope you got this correctly. And we have this one now. Let's have the summation of 3n as n approaches, or as n goes from 1 to 8. So to simplify or to solve this, I hope that you can still remember your sequence or series. I hope this is your sigma. And to do such, we could actually determine the first term. To determine the first term, remember here that your n ranges from 1 to 8. So for the first term, we will replace n here by 1. So a sub 1 equals 3 times 1 plus 1. So the first term of this sequence is 4. For the second term, we will replace the n here by 2. So you have a sub 2 equals 3 times 2 plus 1, which is 6 plus 1 or 7. The third term is 3 times 3 plus 1 or 10. All the way, your last term, which is a sub 8, equals 3 times 8 plus 1 or 25. Note, this should be your last term, considering that it is the upper limit or the number here that you should stop with. And if you have the summation of this one, to evaluate this means 4 plus 7 plus 10 plus all the way until 25. I intend to use the shorter version of the formula because I know the first term, which is 4, the last term, which is 25, and your number of terms, which is 8. So replacing all n's with 8 and with substitution of the others, or by the other values, you have s sub 8 equals 8 over 2 times the sum of 4 and 25. 8 over 2 is 4. 4 plus 25 is 29. And you get a product of 116. Hence, the sum of the first 8 terms of this one, or this summation, has a value of 116. I hope you got it. And if ever there are questions or clarifications, feel free to comment it in the comment section, or feel free to chat me or reach me in my social media accounts. With that, I hope you learned something significant today. Thank you very much, and a great day to one and all.